Hello and welcome to SudoKanard. We're here to solve another puzzle by Richard Stolk, and this is position sums again. I love position sums, and Richard loves position sums, so I thought, no, I can't resist. I can't resist the appeal. And there's a lot of identical clues, so there are the rules of position sums. Such a number on white background is the sum of the first two digits, and the number with a gray background is the sum of the digits whose positions are given here. For example, if this is 5 and 9, summing to 14, then the digits in positions 5 and 9 must be 6 and 8, summing to this gray 14. Right, and that is a way of achieving this. Another option would be 6, 8, meaning that in position 6 and 8 we get the other sum with 5 and 9. And I haven't solved this puzzle yet, so well, this is the moment to start. So there are those two options, and at this point I don't know which one is the correct one. And here is some similar fact. This could be 7 and 8 with 6 and 9 in 7th and 8th position, or it could be here 6 and 9 with 7 and 8 in those positions, in which case this would be a 7, because from what we said, either there is 6, 8 with something in here, or this is 5 and 9 with 6 and 8 in those positions. So in both cases, this is never an 8. So if this is 6 and 9, then this is 7, and this is 8. But there's the option where 7 and 8 are here, and 6 and 9 are there, and I'm not sure how to disambiguate that. And when I say I'm not sure, I have absolutely no idea at this point. All right, so how do we proceed? How do we proceed? That is really confusing. There's 14 here as well. And one interesting fact here, if I try 5 and 9 here, which puts 6 and 8 there, then it tells us that this 14 can't be 6 and 8 because of that. In which case this is 5 and 9, in which case this and that sum to 9, which places 103 here. That would be very interesting. But at this point I don't know that 5 and 9 are really here. Perhaps there is a way of proving that this is this. Perhaps there is a way to prove that this doesn't work. In which case I'm really not seeing how. There are so few clues. How do we do that? An interesting point about, yes, I just have a look at this 8 clue. If I try 1 and 7 here, then this plus that must sum to 8, which is impossible, because this and that sum to 8. So there will never be the 1 here, and the same is true here. I can't have 1 and 6, and here I can't have 1 and 9, and here I can't have 1 and 7. Oh, and the same is true here with 2 plus 6. 2 and 6 here, that would be 2 or 6 as well. So this is 3 and 5. Okay, this is well, and the same is true here, which means that this is 6 and 8, this is 6 and 8, and we have 5 and 9 in those positions. And here, for the same reason, it can't have a 1, it can't have a 2, so this is 3 and 4. Those two sum to 7, those two sum to 8. And here I can't use the 1 or the 2 for the same reason. So it can still be 3 and 7, it can still be 4 and 6. And the interesting point is that whichever I use contains either a 7 or a 6, and this also contains a 7 or a 6. Okay. And by the way, 6, 8, it means that this plus that sum to 9. They can still be 4 plus 5 or 2 plus 7. Except that 4 is not here, so that 5 is not here. This plus that is, this is either 1, 7 or 2 and 6. 6 is not here, so 2, 6 or 1 and 7 in both cells. So those are either 1, 6 or 2, 5. And this never can. Oh, that's interesting. Yes, that's really interesting. I said 1, 6 or 2, 5. This is the 6th cell on this row. And if I try 6 and 9 there, then I must put 7 and 8 in those cells, and that doesn't work. So this is actually 7 and 8 with 6 and 9 here, which disambiguates this pair, this 5 here and 9 there. And that's not a 6, so that this is not 1. Those two digits now sum to 8. They can still be 1, 7 or 6, 2. This is never a 2. This is never a 6. It can be 2. And, oh no, 6 is not permitted here either. So those two cells are 1 and 7. And what about this? So now, I had found that this could not be 1, 9 or 2, 8. It can't be 7 and 3. So this is 4, 6. So those two digits sum to 10. Not sure which digits they are. There are still a number of options. So this is really not that much information to work with. This 9 is not here, so it must appear here or there. So that this is 6, this is 9. So we have more digits now. Here, I still don't know whether this is 6, 9 or 7, 8. Interesting fact is that if this is 6 and 9, those two must sum to 6. So 1 or 2 here, 4 or 5 there. 4 or 5 there, which would mean that this can't be 5 plus 4. That would be very interesting. With 7 and 8, those two sum to 6. I don't know what to do with that case. There again, we have so little to work with. This 9 goes here or there, and there. That's a 9, which means that there is a 9 somewhere around here. This could be relevant for regarding this. Something of interest, we don't have any 6 and we don't have any 8 in this area. So 6 and 8 are somewhere around here. Don't know what to do with that. Definitely they can't both be here, because if I try to put 6 and 8 here, then none of those 2 digits will have to go there, which is incompatible with this 15 clue. So there is at least a 6 or an 8 here, which is a nice bit of logic, but I'm not sure that this will be useful in any manner. This card still needs 2, 4, 6, and 8. So this is 2 or 8. This is 2 or 4. Oh, is that interesting regarding this? It might. I just noticed that this prevents the sum of those 2 digits. Well, it doesn't prevent the sum of these 2 digits from being 10. This is mandatory. But those 2 digits can't be 2 and 8, so they must be odd. They must be either 1, 9, and 3, 7. And knowing that this is not 3, this is not 7. This is almost interesting. If this is 2, then those are 5 and 4. If this is 4, then those are 2 and 7. And I really don't know what to do with it. Okay. I think I said something about, yes. Now, if this is 6 and 9, then it forces this to be a 1 and this to be a 5, in which case this is a 4, and those are 2 and 7, and those are 1 and 3, and I see no objection whatsoever. If this is 7, and 8, then those 2 sum to 6, so that 9 is pushed into this cell. And I don't know what to do with that. Oh, I've been missing a Sudoku elimination. That's a 5. Not that it doesn't seem to matter that much, but actually that's a 3. So there is a 1 in here. That's not 1, that's not 7. And look at that. The 1 is around here. So this is a 2 and that's a 6. Some progress actually. Here we have 1, 4, and 7. So this 6 on this row goes there. This is from 4, 8. Here we need 2, 3, 8. So this is not 2, and this is not 7. Oh, 2 and 4, so that this is 8, this is 2, this is 4. This is 2 and this is 7, because let's remind, I'm being reminded that those two sum to 9. Here I need 1 and 5. And here I need 4 and 9, and there's already a 4 in this column, so that's the 9, that's the 4. This is not 9, this is not 1. And now we know that those are not 6 and 9 because those two digits cannot sum to 6. But those can sum to 6 with a 2 there, so that those are 7 and 8. So 8 is not in here, 8 is there. Okay, some progress has been made. This is 1 and this is 9 to achieve this sum of 10. This is not 1, so this is not 6. By the way, this is 8 and this is 3 and this is 6. Here we need 3, 7, and 8. So that can only be a 3. Here we need 1 and 7. 3 goes here. I need a 4 somewhere there. There's still this 8 and this 15 for the final disambiguations, but we're not at this point yet. This is coming closer, definitely. 1, 2, 7. No, 1, 4, 7, 8. So this is 1 or 4. Two here goes there. That's a 5, that's a 2. We need a 3 somewhere. It can only be here. We also need 1, 4, and 5. So this is from 4, 5. This is from 1 and 5. This color still needs 1, 5, and 6. So this is 5. 5, and 6 there. Here we need 1, 2, and 9. By the way, that's a 4, that's a 1, that's a 5, this is 7, this is 8, and this is 4, this is 7, this is 1, and 1 here. That's a 9, and 1 and 2 there. That's 7, that's 8. Yes, progress. 1, 2, that's a 1, this is 2 and 9. This is either 4 or 7. 4, 7, 9 there. Those are from 3, 4, and 7. And those are from 4, 7, and 6. And those digits are finally from 1, 2, 5, and 9. Okay, so let's move on to the final disambiguation. 1 here doesn't work because 15 would have to be the sum of this digit and some other, so 1 here doesn't work. One here would work with a 9 here and 6 there. Oh, note that none of them is a 4, so we don't get this digit, which means that 15 won't be with 7 plus 8, it will be with 6 plus 9. We don't have an 8 here, so 9 can't be here, so 9 will be there. And there will definitely be a 9 here. So we will need a 1 or a 2. And we will need digit 6 in position 9. 7. No 7 here. No 6 here, so that's a 6. 4, 7 there, so this is 3, this is 4, this is 3, this is 5. So we could have 9 here with the 1 there to take the 9, or 9 here with the 2 here. So that's not a 2. We have a 2-9 pair here, so that's not a 2. Two here won't work, because 2 would mean that this is part of an 8 sum. So it would be 2 and 1, and the sum would be 3. So 2 here doesn't work. So now let's just use Sudoku magic. 2 and 9, that works. So 8 is part of the sum. By the way, that's a 9, that's a 2. This is part of the 8 sum, so that has to be a 6. And the other one is the 2, which is in 5th position. And the rest should be Sudoku. 6, not 4. What am I missing? Yes, 7, 8, 4 here, 1, 7, 4, 7, 4, and 7, and 3. And this is it. So that was tricky. That was tricky. I'm really glad I managed to crack it. But well, such a difficult construction, but as always very elegant. Thanks for watching this video. See you someday on SudoKanard.